Hello class. This week, which is week 7 if I'm not wrong, we are covering chapter 6, which is on flooding. So flooding is a very common thing here in the Boise area due to the Boise River, as you may be familiar with. I think it was last year in 2017. I wasn't here, but I heard that there was a fair amount of flooding near Eagle, for example, in the springtime. So it is common where we live, and it is more common worldwide. In fact, one of your discussion boards, I think is the first one, discussion board 11, is gonna have you go and pick an event of flooding around the world and tell me a few things about it, basically. But you'll see that there are so many flooding events everywhere, or in most places. So it's a very common natural hazard and potential natural disaster. Okay. So before we dive into flooding a little bit more, I'd like to cover the water cycle in case you haven't seen it for a while. So I think we covered it in chapter 1, but still, let's go through it. So basically in the water cycle, you have anything that is in the form of liquid water or solid water playing into this cycle. So you have the oceans are the major reservoir of water, right? We have about 97% of our water is in the oceans. However, that's seawater, right? It's salt water, not fresh water. And then once there's enough heat for evaporation to occur, meaning some of that water is going to go up into the air as water vapor, which is the same thing as clouds, basically. Those clouds are going to travel towards the continents, towards inland, or just around the rest of the oceans. And then once they get to a certain height where it's cold enough, they're going to condensate, meaning that water vapor is now going to become liquid water and is going to fall down as precipitation, as rain or snow or hail. Those are all types of precipitation from that water vapor that condensates. So once that liquid water, or I guess frozen water if you're thinking about snow or hail, falls and precipitates into the land or the ocean, but in this case the land, it's going to do one of two things. The first thing it can do is run off through the surface, so literally run on top of the surface as creeks or streams or just in rills or gullies, and it might end up in local base levels such as lakes, or depending where it falls, it might go all the way back into the ocean. So again, runoff is one of the possibilities that water can take. So runoff. And then the second possibility is that water will infiltrate into the ground, becoming groundwater. So that groundwater is going to stay within the ground for a long time, and it might eventually go up to the surface if there is a pressure differential, or it will remain down here in the ground for a long time until something happens. Maybe we drill it, or maybe, again, there's a pressure differential, or maybe it gets all the way to the ocean through the ground itself. There is a third option, I guess. So the water might, again, run off, or it might infiltrate. There's a third option in which the water infiltrates, but just a little bit, so it stays in that top soil part, and that's called percolation. So it's going to remain in that top soil part, and it's going to be used by organisms and by pretty much plant and fungus and all that good stuff. So okay, so having those things in mind, let's move on to the next slide. When we think about the coalescence, if you would, of water that is expressing itself as runoff, right, that is flowing through the land on top of it and not infiltrating, we think of it as surface drainage. Is going to be the word for that coalescence of that runoff. So when you think about it, when you're on a hill and you're seeing a bunch of rain, that water has got to go somewhere. So initially, the water that is falling on any one place is going to go downhill, right? And it's not going to necessarily go right into a stream right away, because there might not be one where that rain falls. So initially, the water is going to flow downhill as sheet flow is going to be the term for that. After that, enough water particles, if you would, are going to accumulate that they're going to start creating channels, if you would, where there are points of weakness within the soil themselves. Those channels are going to be called rills. So rills are pretty small. In a scale, they're probably going to be between 1 centimeter and 5 centimeters, which is 2 inches. So not very big. And then once enough rills come together, it's going to become a gully. So you guys should be pretty familiarized with a gully. A gully is not very big, but it can still reach up to 3 or 4 feet even, depending on where you are. So again, it goes from sheet flow into rills, then into gullies. And then once enough gullies come together and there's enough water, they will flow into a stream. So the stream is going to be, again, it depends on the scale of it, but it could be anywhere from a couple of meters to, many hundreds of meters in some cases. Okay. So certain streams are going to be ephemeral, So those are going to be streams that are temporary. They're only there during certain times of the year. Other streams are going to be, year-round. So the ephemeral streams are going to be happening for the most part here in the high latitudes. Here they're going to happen during the springtime, and then they're going to be dry during the fall or winter time, right? Okay. And then some streams may be tributaries to other streams or rivers. So, for example, the Boise River is going to be a tributary to the Snake River, which in turn is a tributary to the Columbia River. Okay? So you don't need necessarily for a stream to be the tributary. For example, gullies themselves can be tributaries to streams, right? So certain gulches, for example, here in the Boise foothills, are tributaries to the Boise River themselves. So tributary just means something that is going to flow into a bigger stream and add some water into it. When that tributary pretty much reaches the stream that it's trying to get to, that's pretty much the edge of that tributary. That's where it ends, if you would. So once the Boise River gets all the way into the Snake River, which is the bigger river in this case, the Boise River stops, and then the Snake River kind of takes over that river, if you would. Okay, so as you're seeing here on the picture, the different areas, if you would, where this is occurring are going to be called the drainage basins. So any one area where if the water were to fall here and end up in this stream is going to be a drainage basin for this stream. However, if the water were to fall here, the raindrop, and it flows that way, then it's going to be part of the drainage basin over here, if you would. So the drainage basin is going to incorporate any water that is going to fall within that area. Okay? So a drainage basin is also called a watershed, a river basin, or a catchment area. So you might hear all of these terms. It's not very well agreed upon people, which is what. But again, drainage basin, watershed, river basin, and catchment area pretty much all mean the same thing. So in your quizzes, you'll have all of the answers as the possibilities. That way you don't get confused. Okay, so you see a few more examples down here. There's another example for that drainage basin feature. You're seeing the major stream, which is flowing down here, and then you're seeing a few tributaries to that major stream, and then a few smaller tributaries to the tributaries of the major stream. Okay? Same thing with this one. You're seeing tributaries to the major stream that is later on flowing into, in this case, a big body of water, which could be a lake or the ocean. So, as an example, I have a picture of the Boise foothills right here. And we're going to try to delineate the drainage basin for one of the gulches there. So this is a Harris Ranch, if I'm not wrong, down here, that complex. And then right here, I think this is called the Maynard Gulch. So you're seeing here that this is going to be the major stream, if you would, the major tributary that is later going to end up in the Boise River. So within this major stream, you're seeing that a bunch of other gullies, or yeah, in this case they would be gullies, are being tributaries to that major gulch. So you can see how the drainage basin is gonna play out, but let's do that exercise real fast. So right here we have that same picture, and if we were gonna delineate the drainage basin for the Maynard Gulch, we would go ahead and mark pretty much the highlands. Sorry guys. So if any water drop were to fall to the right of that line that I'm making, it should end up in the Maynard Gulch pretty much. And now if any drop would end up on the left side of that line that I'm making, it would end up on the Maynard Gulch. Okay, so that would be sort of the drainage basin for the Maynard Gulch that again would later be a tributary to the Boise River down here. Okay? Okay, so let me erase that real fast. Okay. All right, so there are two major subdivisions, if you would, within the North America continent. So any water drop that falls to the right-hand side of this line, of the continental divide, that water is going to end up in the Atlantic Ocean. And if a water drop falls on the left side of the continental divide, it's going to end up in the Pacific Ocean. So there are three major drainage basins in the US, and I will show them to you in a second. But basically the major drainage basin in the US on the eastern US is going to be the Missouri-Mississippi drainage basin. And then on the western US, on the northern part, there's going to be the Columbia River Basin. And then on the southern part, there's going to be the Colorado River Basin. But again, the continental divide, which is basically a high point elevation-wise speaking, it's going to divide whether the water that falls nearby is going to flow towards the Pacific or is going to flow towards the Atlantic. So if a water droplet falls in pretty much anywhere in Idaho, it's going to flow towards the Pacific. But if a water drop falls in eastern Montana, then in that case it's going to flow into the Missouri River and then eventually end up in the Mississippi and in the Gulf of Mexico, which is the Atlantic Ocean. Okay? So let's go through. This map is beautiful and I want to show it to you. Okay, so here is a map showing you the different basins in the US. So you see that it's very intricate and it has, for each major stream, there are a bunch of tributaries for each of them. So you're seeing the pink one right here. That's going to be the Missouri River that later on goes into the Mississippi River and ends up in the Gulf of Mexico. That's the biggest drainage basin that we have in the US. And in fact is one of the biggest drainage basins in the whole world. And then you're seeing a few others. So this green one right here is the Hudson River drainage basin. You also have the Columbia River drainage basin up here, and then you have the Colorado River drainage basin down here. All the other ones, I'm going to be completely honest, I don't know the names for, but you see that they're a lot smaller scale than those bigger ones that I talked about. So this is a cool little video. It kind of shows you the Missouri-Mississippi River drainage basin forming based on the amount of tributaries that you have. So let's look at it real quick.